In today's lesson, we are going to continue graphing square root functions. Our last lesson, we were looking at the parent function and then just translating the parent function. But now, we will be looking at other ways the graph can change. So, by adding a number in front of the square root, all of a sudden, we might have graphs that increase a little bit quicker, or maybe ones that are a little compressed, or ones that flip and kind of reflect across the x-axis. So the first example is what is called stretched, being stretched vertically. So if we have, here's like your square root function, stretched would mean, woo, it's going to maybe increase a little quicker, go a little higher. So it will be stretched vertically when you have a number in front of your square root that is greater than 1. So here is an example. Y equals 3 times the square root of x plus 4 minus 5. We're going to plug in x values. We're going to pick x values, plug them into our function, and get our y values. Now, you can kind of just plug in whatever numbers you want, but we do have to be kind of strategic about which numbers we pick. Reminder that we cannot have a negative number under our square root. So we want to know what's the smallest number we can have. Well, we can have 0, but what would make this 0? What would make it 0 would be -4. So that is the first number we will pick as our x value. Now, for the other values, really, you can pick any number bigger than -4 and we can get numbers. However, you'll need a calculator, we might get some decimals, so I'm going to pick specific numbers to avoid calculator and avoid decimals. Remember when we were doing just the parent function square root of x, we were looking at 0, 1, 4, and 9. So now we have x plus 4. What I want to do is pick values of x that still get me 1, 4, and 9 underneath the square root. So how can I get a 1 underneath the square root? Well, I would get that if my x value is -3. -3 plus 4 is 1. How could I get 4? Well, 0 plus 4 is 4. And then how could I get 9? 5 plus 4 is 9. So if I pick these values, it just makes my life a little easier. All right, so if I plug in, I'm going to write this out. 3 times the square root of -4 goes in for x, plus 4 minus 5. What does that equal? Well, -4 plus 4 is 0, square root of 0 is 0, times 3 is 0, minus 5. So -5. I'm going to plot the point -4, -5. Okay, next one. Oops. All right, it's 3 times the square root of, plugging in -3 plus 4 minus 5. All right, so -3 plus 4 is 1. Square root of 1 is 1. 1 times 3 is 3. 3 minus 5 is -2. So -3, -2. All right, 3 times the square root of 0 plus 4 minus 5. 0 plus 4 is 4. Square root of 4 is 2. 2 times 3 is 6. And 6 minus 5 is 1. So 0, 1. All right, now 3 times the square root of 0. Oh, whoops, messed up. 3 times the square root of 5 plus 4 minus 5. 5 plus 4 is 9. Square root of 9 is 3. 3 times 3 is 9. Minus 5 is 4. So 5, 1, 2, 3, 4. So here is my square root function. So it has been stretched. Now, the domain, find our smallest value, which is -4, -5. X value, Y value. So my X values are all x values greater than or equal to -4, and y greater than or equal to -5. All right, the next, instead of stretched, we're looking at being compressed. So if this is the parent function, compressed means it would maybe increase slower. So what would cause that? That is if the a value is in between 0 and 1, so like a fraction. So for this one, we'll have y equals 1/2 times the square root of x minus 1 plus 3. And then I have an x value. All right, so same thing. I can pick my x values, but I have to be strategic. First, you look here. Underneath the square root cannot be negative, but it can be 0. So what makes it 0? The x value is 1. That's the smallest x value. I have to now pick x values greater than 1. But let's be strategic. So for the parent function, square root of x, remember we chose 0, 1, 4, 9. So now let's think about this. How can we get those numbers underneath the radical? So to get 1, well, 2 minus 1 is 1. How would we get 4? 5 minus 1 is 4. And how do we get 9? 10 minus 1 is 9. So let's plug them in. 1/2 times the square root of 1 minus 1 plus 3. 1 minus 1 is 0. 0 square root is 0 times 1/2 is 0 plus 3 is 3. So over 1 up 3. Okay, let's plug in 2. 1/2 square root of 2 minus 1 plus 3. 2 minus 1 is 1. Square root of 1 is 1 times 1/2 is 1/2 plus 3 is 3.5. So we have a decimal, but it's an easy decimal. We can deal with 0.5. So I'm going to go right 2 up 3.5. All right, let's keep going. 1/2 square root of 5 minus 1 plus 3. 5 minus 1 is 4. Square root of 4 is 2. Half of 2 is 1 plus 3 is 4. So over 5 up 4. Then the last one, 1/2 times the square root of 10 minus 1 plus 3. 10 minus 1 is 9. The square root of 9 is 3. Half of 3 is 1.5 plus 3 is 4.5. So go over 10 up 4.5. And then for the domain and range, look at your smallest number. This time it is 1, 3. 1 is the x, 3 is the y. So the domain are all x values greater than or equal to 1, and the range are all y values greater than or equal to 3. All right, and here's our last example. This is a reflection over the x-axis. So if this is the parent function, a reflection would just go the other way. It's going to flip. And that happens when that front number a is less than 0, or in other words, when a is negative. All right, so x values, and here's my function. Y equals -2 square root of x plus 2 plus 1. All right, what is the smallest x value I can have? How does this get to 0? -2. Let's think about those parent function points once again. 0, 1, 4, and 9. So how do I get 1 under my square root? I would get 1 if I plug in a -1, -1 plus 2. How would I get 4? Well, 2 plus 2 is 4. And how do I get 9? 7 plus 2 is 9. All right, let's plug them in. -2 square root of -2 plus 2 plus 1. -2 plus 2 is 0. Square root of 0 is 0 times -2 is 0 plus 1 is 1. So -2, 1. All right, -2 times the square root of -1 plus 2 plus 1. Negative 1 plus 2 is 1. Square root of 1 is 1. Times negative 2 is negative 2. Plus 1 is negative 1. So negative 1, negative 1. All right, 2. Negative 2 times the square root of 2 plus 2 plus 1. 2 plus 2 is 4. The square root of 4 is 2. 2 times negative 2 is negative 4. Plus 1 is negative 3. So positive 2, negative 3. All right, last one. Negative 2 square root of 7 plus 2 plus 1. 7 plus 2 is 9. The square root of 9 is 3. 3 times negative 2 is negative 6. Plus 1 is negative 5. So 7, negative 5. So here, my graph has flipped. Now that is going to impact down here. So my starting point this time is negative 2, 1, where I've got my x and my y. But let's think about this. My x values are still increasing. So x is greater than or equal to negative 2. But this time my y values keep decreasing. So y, instead of greater than or equal to, like it has been, it's now less than or equal to the y value 1. So there is your full lesson on graphing square root functions. Good luck.